Hi everyone, my name is Abigail Loya, and uh, today talking about physical and chemical process. Um, well, uh, Physical and chemical processes are essential to understanding material change. Physical processes like melting and bonding alter the shape or appearance of a substance without changing its chemical composition and are often reversible. In contrast, chemical processes such as combustion and roasting involve reactions that create new substances with different properties and are usually irreversible. These processes are vital in various fields, from energy production to everyday manufacturing, allowing us to control materials and develop useful products. Understanding both types of process helps us harness material effectively and sustainably. Well, first, talking about physical process, and first really melting. Melting is the process by which a solid changes into a liquid. During melting, heat energy is absorbed by the solid, causing its particles to vibrate more vigorously until they can move freely, forming a liquid. This transition does not alter the chemical identity of the substance. The operating condition is melting requires a specific temperature, known as the melting point, and adequate atmospheric pressure. For water, this occurs at the zero center under the standard atmospheric pressure. However, changing pressure can affect the melting point. For instance, ice melts at a slightly lower temperature under reduced pressure. Additionally, impurities in a substance can lower its melting point, a phenomenon known as melting point depression. The second is boiling. Boiling is the process in which a liquid turns into a gas through the liquid, not just at its surface as in evaporation. During boiling, heat energy is absorbed, allowing particles to overcome intermolecular force and disperse a gas. And the operating condition, boiling occurs when the temperature reaches the boiling point of the liquid, where the vapor pressure of the liquid equals the surrounding atmospheric pressure. For water, this boiling point is 100 centigrade at 1 atm. At higher altitudes where atmospheric pressure is lower, water boils at a lower temperature, such as around 95 centigrade at 2,000 meters above sea level. Conversely, in pressurized environments, water boils at higher temperatures, allowing food to cook faster. And the third is sublimation. Well, sublimation is a fast transition in which a solid changes directly into a gas without passing through the liquid state. Sublimation occurs when particles in the solid gain enough energy to overcome intermolecular force and transition into the gas phase. Operating condition: sublimation generally requires a specific temperature and pressure condition where a substance can bypass the liquid phase entirely. Dry ice, solid carbon dioxide, is a classic example. Sublimating at less minus 78.5 centigrade understands atmospheric pressure, turning directly from solid to gas without becoming liquid. Lower pressure favors sublimation. Under such conditions, substances that normally melt may sublimate instead. Another example is iodine, which sublimates reliably at around 113 centigrade when heated in open air. Sublimation occurs at room temperature in some substances, such as mothball, which slowly turn into vapor at standard condition. Well, now talking about the chemical process, and the first will be combustion. Combustion is a chemical reaction between a fuel, usually contain carbon, and an oxidant, typical oxygen, that produces heat and light, often in the form of a flame. During combustion, the fuel combines with oxygen to form products such as carbon dioxide and water. Now, the operating condition is combustion requires the three main conditions known as the fire triangle: fuel, oxygen, and heat. The temperature must reach the ignition point of the fuel for combustion to initiate. For instance, gasoline ignites at around 247 or 280 80 centigrade in the presence of oxygen. Increasing oxygen concentration or temperature accelerates the reaction. Combustion is often controlled by regulating the oxygen supply, which can lead to either complete combustion or incomplete combustion. And well, now the second is rusting, oxidation of iron. Rusting is a slow oxidation process where iron reacts with oxygen and moisture to form iron oxide rust, which weakens the metal structure over time. The operating condition: rusting occurs in the presence of oxygen, air, and water, often facilitated by specific temperatures and pH levels. Higher humidity and temperatures speed up rusting, which is why iron rusts faster in moist, warm environments. Additionally, the presence of salt, such as in sewer or raw salt, accelerates rusting by enhancing the conductivity of water, which promotes oxidation reactions. Rusting is generally irreversible and can be mitigated by keeping iron dry or coating it with protective materials such as paint. Well, the third is photosynthesis. Photosynthesis is the process by which green plants and certain other organisms use sunlight to convert carbon dioxide and water into glucose and oxygen. This endothermic reaction absorbs light energy to drive the synthesis of organic compounds. Well, operating condition: photosynthesis requires sunlight, carbon dioxide, and water, and takes place within chloroplasts in plant cells, which contain chlorophyll. The optimal temperature range for photosynthesis is typically mm, 20 or 30 centigrade. At temperatures outside this range can inhibit enzymatic activity involved in the process, like intensity also plays a crucial role. Low light levels slow down photosynthesis, while very high light levels can cause photorespiration or damage the chloroplast. Carbon dioxide concentration is another limiting factor; higher levels can boost photosynthesis up to a certain threshold. Well, in conclusion, physical and chemical processes are fundamental to how we interact with and manipulate materials in various fields. Physical processes allow us to change the form of substance without altering their identify, identity, making them useful for tasks like purification and separation. Chemical processes, on the other hand, create entirely new substances, enabling innovation in areas such as energy, medicine, and manufacturing. By understanding and applying this process, we can develop more efficient, sustainable methods for creating and using materials, ultimately improving technology and quality of life. Well, thanks for your attention. Well, the, that is, thanks for your attention, and well, bye bye.